For the first, it's the link high availability. Actually, for this morning, there is some partner they ask about whether for Sundray solution we can detect the uplink or some other features. So today, for this afternoon, for the switch, I will introduce about the feature link high availability. The access switch, they usually, for example, if the access switch usually using the dual uplink ports, so in order to ensure the reliability of the uplink and increase the stability of the network, so it's necessary to use a protocol to do the redundant hot backup for the uplink line of the access switch to achieve the interruption of the main line or immediately switch to another devices. So if there is a problem with a line between the aggregation switch and the core, um, the access switch cannot detect it, or the original line is used for the forwarding, and the terminal network cannot be normally at this time. So if there is a protocol to monitor between the core and the aggregation connectivity, when there is a problem with the aggregate uplink, and then it can close the corresponding download link port, and then change the port to the another change to another backup port. So this is the theory about the link high availability. For this link high availability for Sundry, now we have three features. The first is the link backup. The second is uplink monitor, and the third is link aggregation. So let's say the link backup. For the dual uplink networking, um, realize the faster backup of primary and backup link and rapid fault mitigation than STP, RSTP, and MSTP. So the advantage is that for the link backup, it's very fast to change from the failure. For the STP, you can also do like this, but actually for STP, you need to wait after the topology change. You need to wait the forwarding time. After the forwarding time, and it can change the topology. But actually, with the link backup, the fast switch to backup link when the primary link failure, and the time it can reach 50 ms to 200 ms. So it's quite faster than STP. But but it also has the disadvantages because the link backup you need to config. You need to config by yourself. So it's usually used for the small network. For example, in your office, the devices it's not so much, and then you can config for each port. And for the just now we talked about the disadvantage. It's for the link backup. It only used for the small network and not as flexible as STP. For the STP, usually we use for the big network, and if the topology change, it will automatically change, even though the time is much more the time for change will be longer than the link backup, but it's for the big network. For the small network, the link backup it's more useful and more powerful. The second is a backup link group consists two ports. One port works as a backup, and one port as the primary port. So here, this is an example when the link works normally. As we can see, the switch D, they connect to switch B and switch C, and the user's data can be sent from switch D to the switch B and to the switch A. So when the link works normally, the data's direction will be from switch D to switch B and to switch A. Uh, but this is works normally. But what if there is some problem in the uplink? For example, the interface one already has some problem and be shut down. So the interface two, it adds the backup of the interface one. So when the interface one already has system failure, so the backup interface two will be enabled and then to forwarding the data. So after switch D performs link switching, it will send the flash packets to it will send the flash packets from the new broadband link is from the interface 2, and at this time the switch C will check the flash packets whether the packets already whether the VLAN information of the packets be allowed of the switch be allowed by the switch C. So if it's allowed, and then the data can be transmitted by the switch C and to switch A. If it's not in the receiving control VLAN list of switch C, and the devices doesn't process the flash message, and just forwards it directly. If it's in the receiving control VLAN list, so the devices, the switch C will process receiving flash message and then execute the MAC address to and forwarding entry and ARP entry to refresh the operation. The next is the link failure. This is for the switch A. Automatically update the table, the MAC table entry, and through the traffic. So just now, if there is no upstream traffic from the switch D to trigger the update of the switch A MAC address and ARP entries, then when the switch A receives the data, from whose destination devices is the D, but actually hit the MAC address table and the ARP table not refreshing. So he still will forward it through the interface 3 to send it to the switch B. But actually the packet is not available. So it need to wait for the MAC address and ARP entries automatically age and refresh. So it needs to wait for the time to refresh. For the uplink monitor, the uplink monitor is a powerful supplement to backup link technology. The uplink monitoring is used to monitor the uplink to achieve the purpose of synchronizing the download link with the uplink state. To make it more easier to understand, we can see it in this way. The switch monitor the switch monitors the uplink, and when the uplink port fails, and then it closes the download link port to save the intranet bandwidth resources. So it always try to detecting the uplink, to monitoring the uplink whether it has the problem. If there is has the problem, and then the corresponding download link port will be forced to the error down to save the intranet bandwidth resources. This is the picture from the fate from the switch management center to config which uplink ports need to be monitored, and if the uplink ports if this uplink port has the problem, and the downlink port which port will be error down. So you can here to choose. Here is some details. After the uplink monitor is configured, the uplink interface will be monitored in real time. So once the uplink interface fails, including link failure, OEM, single pass failure, or OEM connection cannot be established, then the downlink interface will be forced to the error down stage, and then when after some time the uplink recover, the downlink interface also will be restored. Here there is an example in the switch B. In the switch B, we enable the uplink monitor the interface 1. If the interface 1 has a problem, and then the interface 2 of the switch B will be forced to the error down stage. And for the switch C, when it detects that the interface 2 it's already be error down, and for the uplink, for this uplink already not available, and then it will change to use the backup port. And for the uplink monitoring, there is two situation. When the uplink interface are in smart link group, only when both interfaces in the smart link group are in inactive state, and then the uplink interface are considered as a failure. Because for the smart link group, there is one interface as a backup. So only after the both interface in inactive status, and then we think the uplink interfaces are the system failure. And for the downlink interface, when the downlink interface are in an aggregation group, the uplink failure will force all the downlink interface in the aggregation group to the error down. So it means for the downlink interface, if in this group there is many ports in the aggregation group, so when the uplink interface system failure, all the downlink interface in the aggregation group will change to the error down. All the ports in the group will be changed to the error down. After the interface in the aggregation, after the uplink restored, and all the interfaces in the aggregation group will be restored. For next one, it's the link aggregation. in the link aggregation, in the link aggregation, we can aggregate multiple ports in a group. And there is two ways for the link aggregation. The first is the manual static aggregation, and the second is static LACP aggregation. And for both of these aggregation methods, we need to make sure the switch have the following attributes. The first, the ports are in 4 duplex modes, and the second is the port rate is the same. And ports are both access ports or belongs to the same VLAN or trunk ports. It means all the VLAN settings of the ports should be the same. If it's the layer 3 port, then the corresponding aggregated ports will also be the layer 3 interface. For the first manually load balance, in manually load balance mode, usually we establish the Ethernet trunk by manually join the member ports. We manually config which ports are in the group, which ports are not in the group. And in this mode, all the active links participate in data forwarding and share the traffic evenly. So it's called manual load sharing mode. And for this mode, we need to make sure when the layer 2 Ethernet interface needs to be aggregated, and then the interface type need to be selected as the layer 2 interface. And if you want to aggregate the layer 3 Ethernet interface, you need to select as the layer 3 interface. You just need to make sure what kind of what layer you want to aggregate the ports. For both for the both ends of the aggregation link, it should be configured with the same interface type. In this mode, the joining of the member interfaces is manually configured. The second one is the LACP link aggregation. In order to further manually load sharing mode, because you need to configure manually, and it's not so convenient. So in order to improve the fault tolerance of the inner trunk and to provide backup function to ensure the high reliability of member links, so now we can use the link aggregation control protocol, use LACP. And how the LACP works? The LACP, it provides a standard negotiation methods for devices that can exchange data, so that the devices can automatically form the aggregation links, and to start aggregated links to send and receive the data based on their own configuration. And also in this mode, the join of the member interface is manually configured. You still need to choose which interface are in this link in this group. For the active member link, we usually used for the data forwarding in load balance mode, and for the inactive member link used for the redundancy backup. If an active member link failure, the inactive member link with the highest priority will replace the failed active link. The status change from an inactive link to an active link. This means it will to replace the failed active link to the new to the active link. So what's the difference between the two ways of link aggregation? In the manual load balance mode, all the ports are in data forwarding state. But in the LACP mode, some links will act as the backup links and it's not forwarding the data. And in aggregation port, all the parameter of the member ports must be consistent. So you need to keep the configuration the same. The parameter include the number of physical ports, transmission rate, duplex mode, and flow control mode, and whether it's layer 2 or layer 3 port. Also, in order to avoid the out of order sequence of data packets caused by the inconsistent rival order of data frame due to the transmission of multiple member ports. The link aggregation use flow-by-flow load sharing mechanism. So it's also a big for the flow-by-flow load sharing mechanism. It's also a big progress for the LACP protocol. And here there is a question: when two links are aggregated together, how does LACP select the active member link? For the both devices, as the both ends will receive after we enable the LACP, right? For the both devices at both ends will receive LACP DU message from the opposite end. So for the opposite ports, it sends LACP to each other. Here I just take device B as an example. When the device B receives the message from the device A, the device B will view and record the peer information, and then to compare the system priority. If the priority of the device is higher than the local system priority, and then it will determine that device A is the LACP active ends, because the device A, the LACP priority is higher than device B, so it thinks that device A as the active end. And then after the active end is selected, the both ends will select the active interface according to the interface priority of the active ends. The devices on both ends select the same active interface, and the active link group can be established. So after this, the active interface be changed. For the active links, the load sharing is used for the link and to forward the data. Though the theory of LACP it's hard to understand, but for the configuration, it's not so hard. Before the configuration, for the fate switch modes, before configuration, we need to check whether the attributes of the interface are the same. So, for example, before you want to aggregate the interface 1 and interface 2. So you need to make sure the interface 1 and the interface 2, all the settings are the same. The VLAN settings, or the layer 2 or layer 3 interface, or the working mode, all the information should be the same for these two parts. And then to select the devices type, to choose whether the working mode is manually load balance or LCP, and just to choose the interface 1 and interface 2. Also select the interface type, load mode, or and ports to be aggregated, and configure the attributes of the link aggregation group. After aggregate the interface, what's the settings? What's the VLAN settings? Access VLAN, VLAN 7. So after we configure, after we choose the switch and to choose the mode as the manual load sharing scam, and choose the type layer 2 interface, and also choose the load sharing scam. It's destination and source MAC address based, and we choose the member, choose the interface member of the interface, and then we give the settings for the VLAN. After this, which click OK. So these two ports will be aggregated together. It's not the configuration is easy, right? You just need to choose some key parameter. And for the fight switch mode, also before the configuration, you need to check whether the attributes of the interface to be aggregated are the same. And the first, you select the device's type, and then choose whether the work mode is manually load or the LCP, manually load sharing scam or static LCP. And then choose the ports which need to be aggregated together, and set the VLAN for it. Access VLAN, trunk VLAN, just according to your requirements. Yeah. For the link aggregation, it's already finished like this.